Hi guys, this is a video tutorial about numpy. We have already used numpy in the previous video. In this video we are going into the detail of numpy. If you are an R user, you will find numpy very intuitive because basically it implements vectorized operation, and we will see some examples later. So the plan for this video. We start by creating arrays, sequences, matrices. We see indexing and slicing, how to make a copy, how to use newaxis, row bind, column bind, concatenate, split, repeat, vectorization, some math operations, aggregation, operations with missing values, boolean, if else, sort, unique values, randomness with default underscore RNG. So this is the plan of the video. You will find the timestamps in the description below. So if you're interested only in some part of the video, you can just jump to it. Let's start. We import numpy as np. Let's create an array. So we pass a list to np.array. We can print this array and we can check the data type. So we have int 64. We can set the data type. So for example, we create this R array and we set dtype equal float 32. And as you can see now, data type is float 32. Naturally, we can generate a list and pass the list object to the array. If we want to create an array of zeros, we just use the zeros function. So zeros 5, we have 1, 2, 3, 4, 5 zeros. And again, we can set the data type. Now, let's create the sequences. With a range, we create a sequence from a starting point to an end point excluded. And we can set the step of the sequence. For example, from 0 to 10 excluded by 2, so step equal to. This means that we have 0, 2, 4, 6, 8. We have also linspace, so in this example we create 5 values evenly spaced between 0 and 10. And this time 10 is included. Now let's create matrices. We just use a list of lists. So we pass this list of lists in array. If we want a matrix of zeros, we just set the dimensions. For example, a 4x4 matrix. We can also generate a matrix of ones, for example, a 2x2 matrix of ones. If we want an identity matrix, we have to use I. So I for generate an identity matrix 4x4. Now let's generate some random matrix. So 4x4 matrix with random values between 0 and 1. A 4x4 matrix with normally distributed values with mean 0 and standard deviation 1. Then we have a 4x4 matrix with random integers between 0 included and 10 excluded. And now we generate a 3-dimensional array with values between 0 included and 10 excluded. So here we have 3 matrices. Each matrix is 4 rows and 5 columns. Okay, let's generate a 3x4 matrix. We can check the dimensions, the sides of each dimension. So here we have a 3x4 matrix and the total size of the array 12. Indexing and slicing. So here let's generate this sequence. Let's retrieve the first element Python starts indexing from 0, so the first element is stored at index 0. Here we retrieve -10. Let's retrieve the last element, so negative numbers start from the right, so -1, we retrieve 10, -2, we retrieve 5, and this is the same as index 3, because 0, 1, 2, and 3. Let's see this notation. Colon, this means from the beginning to index 3 excluded. Now we have index, column, this means from index 1 included to the end. The notation is start, stop, step. By default, step equal 1. So if we do 1, 4 means from index 1 included to index 4 excluded, step 1. So we get -5, 0, and 5. If we write 0, column 5, column 2, we get from index 0 included to index 5 excluded, step 2. So we get -10, 0, and 10. If we want to reverse all the element, we use colon, colon, -1. We reverse all the element. Let's subset, so we store the index that we want to subset for, so 0 and 3 in this case, and then we pass to S. Let's see with matrix. So we have the A matrix. Again, Python starts indexing from 0, so the first row, first column, they are at indices 0, 0 in Python. So here, 0 and 0, we are retrieving basically first row, first column, so 1. This one is the first row and fourth column at indices 0 and 3. Second row and fourth column at indices 1 and 3. We can replace a value, so we replace the value 10 at index 1 for the row and 3 for the column. We can slicing multiple rows and columns, so let's see. With this one, we retrieve the first row. So we want the first row, comma, all the columns. Okay. Here, this means all the rows for the column at index 2. Okay. Erase and copy. So B equal to A. Now let's replace 0, 0, so 1 with 10,000. Now what is the issue here is that if we check A, also A changed, as you can see here. If we want to avoid this behavior, we can use copy. So now we make C equal A dot copy. And now let's modify row index 0, column index 1 with 200,000. If we check now A did not change. From row vector to column vector, okay. So this is our S. Now I want to print as a column vector. So column, comma, and then we use np dot newaxis. Here we print as a column vector. Let's see row bind and column bind operation. So we have a list A, B, and I want to put together in C. If we do like this, as you can see, I have a list of a list. I don't want this. I want just one array. I can use, in this case, for example, H stack, horizontal stack. So I pass A and B. And as you can see now, D is just one array. Again, I can print as a column vector. So we have also v-stack, so for vertical stack. So now we have one above the other one. This is the same as row stack. And then we have also column stack. Concatenate. Let's generate the R object. Let's concatenate S and R. Let's concatenate R and S. Let's store in T. Now let's check data type for R. This was integer 64, but in T we have all float 64. Okay, we can use concatenate. So we have A, B, C. These are the matrices that we built earlier. So we have the first matrix, the second matrix, and the third matrix. We can check the shape. So we have 9 rows and 4 columns. And when we concatenate, we can decide the axis. So axis equal 1, we are referring to columns. So here, let's check first the shape. We have 3 rows and 12 columns. So this is the first one, the second one, and the third one. As you can see, we have 1, 1, and 1 that makes the first row. Then we have this, the second row here, second row here, second row here. This makes the second row here, and then third row, third row, third row. That makes this third row here. Okay, let's generate a Z array. Now let's vertical stack A and Z. We are generating this W. When we work with a vertical horizontal stack, we have to be careful to the dimensions. If now we want to horizontal stack W and Z, we get an error and say that the problem is with the number of dimensions. In this case, we can transform Z, and now we matched the dimensions. Split. Okay. This is our A object, and I want to split in five parts. So let's print. We have -10, -8, so 1, 2, 3, 4, and 5. We can also decide the number. So here 3, 7. What does it mean? From index 0 to index 3 excluded, so means to index 2 included. From index 3 to index 7 excluded, so to index 6 included, and from index 7 to the end. So this is what we are doing. Let's see split with a matrix. Vertical split from row at index 0 included to row at index 2 excluded. So we generate this upper and lower. So row index 0, row index 1, and then row index 2. We can do left and right with edge split. And in this case, we split left, center, and right. Repeat. Let's repeat 5 times. If we have an array, so we have an A array 1, 2, 3, we want to repeat the array, we use tile. In this case, tile A 3 times. As you can see, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, vectorization. we have this list A. Our task is multiply 2 times each element in list A. In Python, if we do 2 times A, we repeat the list 1, 2, 3, 4, 1, 2, 3, 4. So the list is repeated twice. So how we can do in Python? We can use a for loop. For I in range length A, print 2 times A at index I. So we have 2 times 1, 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8. But in NumPy is much convenient, and this is the same way that we do in R. So B, we pass A, the list A, to array, so we generate this B, and then we can just multiply 2 times B. We get 2, 4, 6, 8. Let's see, we have a list of a list, and I want to divide 1 by each of the entries. So with Python, I'm using a nested for loop for I in range 3, for j in range 3, print 1 divided Lij. So we have 1 divided by 1, 1 divided by 2, by 3, by 4, by 5, 6, 8, 9. But with NumPy is much easier. We generated the A matrix, we just divided A by the matrix, and we get, as you can see, the same result. Let's see some math operation. So this is natural log, the power. This is the power in Python. Exponential, sine, cosine, floor division, and remainder. Aggregation. Let's generate A. So now let's sum all the elements in A with the sum function from NumPy, sum from NumPy. We can make a cumulative sum. We can find the maximum value of A and the minimum value of A. Now let's generate this matrix. Again, we can sum, find the minimum value, and find the maximum value. We can also find the maximum minimum values for each in the rows or in the columns. In this case, we have to use the keyword axis. But be careful. The axis keyword specifies the dimension of the array that will be collapsed rather than the dimension that will be returned. Let's see what does mean. Let's see, we want the minimum value, axis equals 0. So we want the minimum values in each column. So let's run here. We are getting -10, -7, -10, 2. Why? Because in this column, the minimum value is -10. Here, the minimum values is -7. Again, -10. Here is 2. Okay, so axis equals 0. This is the dimension that collapsed. If we do axis equal 1, in this case, we are checking for the maximum value in each row with axis equal 1. So we have 9, 4, 2, 6. Here, in the first row, the maximum value is 9, 4, 2, and 6. Operation with missing values. Okay, so we use none, not a number from NumPy. So we have this A object. Let's sum A. If we do like this, the result is not a number. In this case, we have to use non-sum. The same applies for max, for example. In this case, we get not a number. With non-max, we get 100. Boolean. Okay, let's print again A. Now we want to check where A equal to 3. The result is false, true, false, false. Is not a number. false, false, true, false. A greater than 50. We have false, 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 true. We can also do like this. Same result, false, false, true. Okay, count entries, count non-zero. So we have 4. Let's generate this array. Now, let's check how many numbers greater than 0. So sum b greater than 0. We have 6. We have 1, 2, 3, 4, 5, and 6. Okay. So how many numbers less than 0 with sum b less than 0? We have 3 because we have -4, -1, -6. Any number less than 5, let's check it. The answer is true because we have -6. We can also slice, so slice if b is greater than 0. So we have 4, 4, 7, 4, 1, 7. This works also with matrix. So a greater than 0, the first entry is false, second is true, this one is also true, and last one is false. If else, okay, task, return greater if b is greater than 0 and less if b is less than 0. Let's print again b. Now in Python, we can use a for loop with if else condition. So for I in range length b, if b index I is greater than 0, print greater, else print less. So we have greater, less, greater, greater, less, less, and we have less, greater, greater, greater. Okay. With numpy, but I just was thinking that, okay, we should write less or equal here, but okay, now I set like this. That's not the point. Let's continue, sorry. With numpy is much easier because we have where function, and this where function works like if else. So where b is greater than 0, print greater. Otherwise, let's correct here, less or equal to 0. Okay. Here we have greater, less or equal to 0, greater, greater, less or equal to 0, less or equal to 0, and so on. Okay, so as you can see, with numpy, just one line of code, very simple. Sort. Okay, let's generate this array. Let's sort it. Now, when we run again b is not sorted. If we want to sort the array in place, we use dot sort, the method sort here. Now, when we run b, as you can see, b has been sorted. Unique values. Okay, here I want to return values and the counts for the values. So in unique, I set return underscore counts equal true. When we do like this, the first here stores the values. Which values we have? We have 0, 1, 2, and 3. How many of them? 0, we have one value. So if we check here, 0, we have only one 0. Then 1, we have 4 values, 1, 2, 3, and 4. Then we have 2. We have 2 here, here, and here. And then we have 3 only here. Okay, so almost done. Okay, randomness. I show you with default underscore RNG, and I leave you a link to this article, Stop Using numpy.random.seed from Towards Data Science. I think that explain very, very well this point of set seed for replication. You find the link in the description below. Let's generate a coin. So coin underscore toss, H for head and T for tail. And let's simulate a coin toss with choice. So choice coin toss 3 times. And by default, choice use replace equal true. So we have tail, H, tail, head, head. If we set replace equal false, so twice, so we have head and tail, and naturally, since we have only two options, head and tail, we cannot set 3 times with replace equal false. In this case, we can just we get an error, cannot take a larger sample than population when replace equal false. Now the point is how to set the seed for replication. I want that you replicate my same result with this. As you can see, if you replicated the video, you see that when you replicated the random example, your results are different from mine. If I want that you, if I want you to replicate my exact result with random generating numbers, I use default underscore RNG. Let me show you how it works. So I generate RNG as mp.random.default underscore RNG and set a number. So in this case, 1, 2, 3. Now let's simulate again a coin toss 10 times. So we have head, tail, tail, head, tail, head, 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 head. Now when I do exactly the same, so RNG random default underscore RNG 1, 2, 3, and the choice coin toss 10 times, I get exactly the same result. Now, let's say that I want to repeat this simulation 3 times. So I use a loop here for I in range 3, and I print the result. This is run 3 times. So as you can see, the first one is the same as this one, but the second and the third are different. But the point is that now, if I want to replicate the same, so I run again, this is the same code as before. As you can see, the first one is equal to the first one, the second one is equal to the second one, and the third one is equal to the third one, okay? So we reached the end of this tutorial. In the description below, I link the videos where I use numpy to build function for some application, for some examples, okay? So I hope the video is useful, and thank you for watching, and see you in the next video.